Hello everybody and welcome to episode 4 of Remaking Cavestory in C++. This episode is called Drawing Our Character. My name is Limeotes, my website is limeotes.com, my Twitter is @limeotes, and my GitHub link is right here. That's where all the source code can be found. Alright, so in this episode, as the title suggests, we're going to be drawing our character to the screen. So let's first identify the problem we'll be solving. There's a few. We should put our comments in header files. Yeah, while I was going through this before, I realized I started putting my comments in the CPP files, and it's much better practice to put them in header files. So we're just going to be moving some of our comments around and putting our new ones in the header files. Then we need to be able to draw things to the screen, and more specifically our game character, whose name is Quote. So we're going to be working with that. Our graphics class doesn't do much right now, so we're going to be adding a lot of functionality to the graphics class. A lot will be handled by that, so that'll be helpful. And then finally, we can't load PNG files just yet either. SDL only, as far as I know, lets you load bitmap files, BMP files, and we don't want to deal with those. PNG is much easier to deal with because of transparency and all that kind of stuff. So we'll be converting all the files to PNG files and getting a special library for loading PNG files in SDL. So a few details that are important to note before we get started. The sprite sheet for Quote. I'm going to show it to you and where to get it. Since this is our first time getting a sprite sheet from the game files, I'll show you where to get it from. It's called mychar.png. So if you go into, I gotta switch to this. If you go into the Cavestory folder and then into the data folder, you will find all of these PBM files. So if you scroll down, you'll find mychar.pbm. So that's the sprite sheet we want. So what we're going to do is, before we do anything actually, let's first go into our project, right click on the project, create a folder in the project root called content, and then inside that folder create another folder called Sprites. That's where we're going to put our sprite sheet, all of our sprite sheets. So now what we can do is we can open up that content folder that we just created, go into Sprites that we just created, copy over. I recommend you don't just move it. I recommend you copy it so that the original stays here. Otherwise, you might have to re-download it again if you mess something up. So copy it, paste it in there as the PBM. Then open it with a paint or image program of your choice. You can use Photoshop, Paint. I'm going to use GIMP for this just because it's free. So any of you can use it, and it's very easy. So there it is, it's open. You don't have to do anything to it. I'll zoom in just so you can see it close up because it's pretty small. This is our sprite sheet. In the next episode, I'm going to go over what sprite sheets really do for you, why it makes sense to have them like this, set up like this. You don't have to worry about for this episode. So you're going to want to save it as a PNG file. In GIMP, to save a picture, you have to actually click Export As, and then change it to PNG file, rename it to mychar.png, export, and export. So that's all for GIMP. Close out of whatever program you just used, and now in my folder I have mychar.png working properly. So now you can just delete the reference or the copied PBM file, and we're ready to keep going. So now it's in there. If you refresh in Eclipse or whatever you're using, you see in Sprites now we have a mychar.png, and that's perfect. So we got that taken care of. Anyway, we're going to want to also download SDL image. We'll do that in a second. That's the library for loading PNG files. And then another important detail that will be important at the end is all sprites, as far as I know so far. I'm obviously not very far into making this game yet, but as far as I know, all sprites are scaled by 2, so they're doubled in size. So we'll take care of that when we're drawing the sprites. So now the solution. How are we going to solve all these problems? We're going to first download and add STL image to the project includes. Then we're going to convert, we already did this, we just did this, convert mychar.pbm into PNG, so that's done. We're going to modify the graphics class to draw to the screen. We're going to implement a sprite class, which is going to handle all sprites, and everything we're drawing to the screen pretty much is going to be a sprite. We're going to add some safe global variables. I put the safe in brackets here because generally global variables they can be dangerous. They might be frowned upon in some programs. They're necessary for us. In game development, it's different. You need global variables sometimes. It's just a matter of doing it safely. So we're going to add some safe global variables. And I'll explain why they're safe when we make them later. Then we're going to modify the game class to draw the sprites. And finally, we're going to add it all into game to draw the player to the screen. So that's how it's all going to come together. So let's just do these things in order. First, let's download and add SDL image to project includes. Now again, I already have it downloaded, but if you go to, I actually provided the link in the details. If you go to this website, libsdl.org/project/SDL image, you'll end up on this page. You want to go down to development libraries, and if you're on Windows, download the one that you need. We went over this for downloading SDL in episode 1. If you're on a Mac like me, you're going to download this, and it's the same deal. The same exact way you got SDL2 set up, you're going to set up SDL image. So you're going to download it, and then you're going to add it to your linker flags. So once it's all downloaded and in the frameworks folder if you're on a Mac, or included if you're in Visual Studio, go right click on your project, go to properties, and then in C++ build, click settings. If you're in Eclipse, this is. If you're in Visual Studio, it might be a little different, but we've already done this. Wherever you added the linker stuff for SDL2, you're just going to add on framework SDL2 image. So that's if you're in Eclipse. If you're in Visual Studio, you're just going to add some more linker stuff, just like this. Hit OK, and you're done. SDL image is now completely included in our project. Since we're already pointing to library frameworks for includes, it's just going to be included. So now we can include it anywhere we need to, and it will work. So that's done. We already converted this. So now we're going to go ahead and get started with modifying our graphics class. So to begin with, let's go into graphics.h. We're going to move some of our comments. Right now we only have this one. So we're going to leave that there actually, but in here we're going to also put this because it's important to know what the class does when you're just looking at the class definition like this. So we're going to add a few functions now. We are going to add SDL surface load image. So what load image is going to do, we're going to put a from now on in our header files, we're going to try to put comments like this. We'll put the return type and the name of the function, and then we'll just write a comment about it. It doesn't have to be long. This one is actually a bit long because I want to explain what exactly is going on. So it's going to load an image into the Sprite Sheets map if it doesn't already exist. Now let me go ahead and create the Sprite Sheets map so that we know what that is. For this, we're going to have to include map and string, which we've done before in a different file, I believe input. So we're just going to add a private variable. It's going to be std map, std string, and sdl surface Sprite Sheets. This Sprite Sheets variable, this map, is going to hold in memory in our graphics object every sprite sheet we've loaded into the game. The benefit of this is that if we're holding on to all of them the entire time graphics exists, then we never have to load an image more than once. And we're going to write special logic in load image to check if it's already been loaded before, and that way we don't have to load it again, which is slow. Constantly loading images takes up a lot of memory, and it might affect our performance, and we don't want that. So if it doesn't already exist, it will load it. As a result, each image will only ever be loaded once. And that's great for everything I just mentioned before. And then it returns the image from the map regardless of whether or not it was just loaded. So whether it loads it into the map this time we're calling load image, or it had already done it earlier when the game was running, it'll still return it, and we're going to use that return value to store it in the sprite later on. Alright, next we're going to create a void blit surface. Now this is getting into actually drawing this stuff to the window, to the screen. So SDL rect source rectangle and SDL rect destination rectangle. So if you're familiar with SDL at all, or even I think XNA used blit surface, that terminology. I know some Python game development libraries use it, like Pygame. Blit surface is what draws images, so SDL textures, to the screen. So we're going to be using that for all of our drawing. So put our comment blit surface and draw the texture to a certain part of the screen, and that part of the screen is whatever this destination rectangle is. So the source is what we're drawing to the screen. The source rectangle is what part of this source we're drawing to the screen, which is where sprite sheets come in. So we're only going to be drawing a little part of that sprite sheet, which is source rectangle, and then destination rectangle is where on the screen we're drawing. Next up is void flip. Well, we're not implementing it here. Void flip. And this renders everything to the screen. And then void clear. And void clear clears the screen. Now, I want to take a second to explain how rendering works in SDL2. So what we're going to be doing is every time we draw from the game loop, which is going to be every frame, we're going to first clear out the render. This will, whatever's on the render is what's going to get drawn to the screen. So we want to clear it at the beginning of each drawing cycle. And then we're going to actually blit surface, we're going to draw to that render after it's been cleared out. And then flip will take whatever's on that render and actually draw it to the screen. So all three of those are going to be necessary for drawing. Okay. And then we're going to have one more helper function down here. It's going to be SDL render get render. It's going to be a const. We're just returning we're just going to return our render so that we can use it elsewhere. We're going to need it in the Sprite class. So I'm just going to say returns the render. Alright, so let's go ahead and implement these. So graphics.cpp. Now up here we're going to include SDL2 SDL image.h. I'm sorry, SDL2 image / SDL image.h. There we go. Alright, so now nothing in the constructor or the destructor is changing. We're just going to go right to implementing our load image. Again, it takes a const std string file path, which is the location of the image, the file path. So now we're going to check if it's already been loaded before. So if this sprite sheets.count file path equals 0, then that means that it hasn't yet been loaded. It can't find it. The maps count takes in takes in the key for the map, so the string, the file path, and then it checks if it tells you how many exist with that key. So if it's 0, that means it hasn't been loaded yet, and that means we need to load it. So sprite sheets at file path equals image load. So this is the SDL image function for loading PNG files. File path dot C string. It takes a C string. Yep. So that's what we do. And then no matter what, we're going to return sprite sheets at file path. So if it just loaded it, great, it's in there, we're returning it. If it already loaded it a long time ago, still great, it's going to just return it anyway. So that's how we load it without, that's how we make sure we're only ever loading each image once. Okay, next we're going to implement blit surface, which takes an SDL texture, an SDL rect, source rectangle, and an SDL rect destination rectangle. Surface. Good. So there's a SDL function called SDL render copy, which is what we're using for this. This copies whatever you pass it, it copies it to the render. So our first argument is actually the render that it's copying it to. Then we give it the texture we're copying to the render. Then we give it the source rectangle, so what part of the texture we're copying, and the destination rectangle, which is where on the render to put it. That's it. Next we have graphics flip. And this actually draws it to the screen. So we're going to call another SDL function, SDL render present. And all it wants is the render. So it already knows what to draw because it's already on the render. So it's just going to draw it to the screen. And then finally, graphics clear, which calls SDL render clear on the render. And as I said before, that just clears it out. And then finally, our SDL render graphics get render const return our render. And that's it. So we're going to use that in a second, actually, in the Sprite class that we're about to make. And that's our graphics class that can now draw things to the screen. So the next thing we need to do in our notes is implement a Sprite class. So let's do that. Let's go into our header files and create new file, sprite.h. Okay. And then we're going to put our header guards in. Okay. So class sprite. This class is a bit smaller than the graphics class, so it won't take too long. We're going to have a default constructor, which we'll need later. Sprite. This is our real constructor that we'll be using a lot. So it's going to take a graphics, obviously. The file path, so where the image is. The source X and the source Y, which are going to be important because we need to know where on the sprite sheet to get the image from. Int width, int height, that's the height and the width of the sprite sheet. I'm sorry, of the sprite. It's the sprite on the sprite sheet that we're trying to get. And then a default position X and position Y. That's just where the sprite's going to start out on the screen. We're going to factor that out when we create the animated sprite class next time. But for now, we're just going to get it in here. We're going to have a virtual destructor for Sprite. We're going to have a virtual void update. The reason it's virtual is because we're going to have some stuff in the update probably, but we're going to be overriding it in animated Sprite and that kind of stuff. So it has to be virtual. And then eventually the player class and enemy classes and everything, they're all going to be derived from this Sprite class. Whether it's from directly or indirectly, they're all going to come back to this. So it has to start out virtual for update because they'll all have their own stuff. Void draw. We need graphics. We need an int X and an int Y of where to draw. Okay. By the way, since this is a class, this all needs to be public. And now for our private variables, we're going to have SDL rect source rect. So that's where on the sprite sheet to get the sprite from. The sprite sheet that is actually responsible for this particular sprite. And then our X and Y position. The X and Y position of the sprite that we're using. Okay. So I didn't put any comments in here. Let's go ahead and write Sprite class holds all information for individual sprites. All of these are pretty obvious what they do. I can add comments later. I probably won't because there's really nothing special going on here. The regular draw, update, and just constructors and destructors and stuff. So all of that's fine for now. So now we can implement this. Go to your source folder and add a Sprite.cpp. We're going to include Sprite.h and include graphics.h. So our default constructor, we're not going to implement right now. It's going to give me a warning, but I'm not going to worry about it for now. The warning is that I'm not initializing my stuff in the default constructor. We're going to initialize it in the next constructor though, so we don't have to worry about it. So graphics, this is just everything I have in the other file. Except now we're going to implement it. Now we're going to use this kind of constructor. We're going to say x pos x, y pos y. And now we just have to set our source rectangle and our sprite sheet. So source rect.w equals quick. So that's our source rectangle where we're actually going to be drawing from the sprite sheet. Now we have to create our sprite sheet. So this sprite sheet equals another SDL function, SDL create texture from surface. Now we're already including SDL2 on Sprite.h, so we don't need to include it here too. I think. Are we? Or not? Well, we should be. That's going to give us an error if we don't. So back in Sprite.h, I'm going to include SDL2, SDL.h. Okay. So create texture from surface takes what? It takes a render and it takes the surface. So this is why we created the getRender function. We could say graphics getRender, and then our surface is going to be graphics.loadImage file path. So if we already loaded it somewhere else, it'll just give us the surface. And if we haven't yet, it'll load it right now and again give us the surface. And then it'll create the texture, and we're storing that in our sprite sheet. So that's how we load our image. Now we're just going to say if sprite sheet is null, that means that we had an error while loading the image. We're just going to printf error unable to load image. So that's helpful for debugging. It doesn't really matter in the long run. We'll get rid of it eventually once we know everything's working. But that'll be helpful in case we have path issues with where we're putting our sprite sheets and that kind of stuff. If it's looking in a different place than we're expecting. So now, the destructor, we're not implementing right now. We don't really care about it. There's nothing to really do with it. Now, sprite draw. This is an important one. This is what's actually going to be doing all the drawing. Which means that we need to call blitz surface that we created in our graphics class. And to do that, we need a destination rectangle. So we're going to create that. An SDL rect destination rectangle equals x, y, and then we need the width and the height. So source rect w, source rect height h. Close that. So that's our destination rectangle. That's where on the screen we'll be drawing. Then graphics.blitzSurface is what's going to be doing the drawing. So blitzSurface wants, if we remember, a texture. So that's going to be sprite sheet. It wants a source rectangle, which is a pointer to a source rectangle, sorry. So it's going to be this source rect. and then a destination rectangle pointer. So destination rectangle, which we just created. Done. And that's how we draw. And then eventually we're going to implement update probably for Sprite, so I'm just going to do that, just so that it's in there. Okay. So that's our graphics class. I'm sorry, our Sprite class. I know I have errors. I'll fix them in a second. It's probably include errors. What is the problem here, actually? The problem here is that I didn't forward declare graphics. I need to forward declare graphics so that in here it knows what that is. Alright, that's better. And then use of undeclared identifier std. What? Out of line definition of sprite does not match any declaration. I've never seen an undeclared identifier std. That's very interesting. Oh, you know what the problem is? I'm not including string. I gotta include string. There we go. Alright, make sure you don't forget to include string in the header file. So now you have no more build errors. If we run this, nothing's going to change. It's still going to just be a black screen. There it is. Lovely. Okay. So now, did that close? Yeah, alright. So now, what we need to do if we go back to our notes. Yeah, global variables. So now we're going to go into our headers. So the problem is, actually, we'll do that last. We'll do global variables last. Okay. Instead, we're going to modify the game class to draw sprites. So to do that, go into game.h. The reason I'm doing it in this order is you're going to see why we need the global variables in a second. So in your private variable, well, first include sprite.h at the top. And then we're going to create a sprite called player in our game.h. And that's it. Then go into game.cpp. And up here, we don't need to include sprite.h because we already are in the header file. Go down into our game loop, and underneath SDL event, we're going to say this player equals sprite, and now we're going to use our sprite constructor. So it takes graphics, it takes a path, so it's in content sprites my char.png. Alright, and now it takes the source x and the source y. That's 0, 0. The reason for that is if we open up our mychar.png here, I'm going to open up in GIMP again quickly just to show you something. The reason why we're using 0, 0, it goes by pixel. So what's the best way for me to show you pixels? Let me bring this down to 1. Alright. So if you look closely, this is the very top left of our sprite sheet. So up here where my mouse is, this is 1 pixel right here, 1 pixel. Each of these little tiny blocks here is a pixel. So the size of the first one is 16 by 16 pixels. So it starts up here at 0, 0, so that's source X and source Y, that's the starting point. And then the width is 16 and the height is 16. So that entire thing is one big rectangle, which is our source rectangle. And that's how we grab this first piece of the sprite sheet. Later on, next episode, when we do animations, we're going to then grab this next one by starting here at 16 and going 16 more pixels over to get this picture. And that's how sprite sheets work. We just move over a certain amount of pixels based on the width, and we can grab from the sprite sheet. But the important thing for now is that the source X and source Y is 0, 0 because we're starting right up here in the top left corner to get this sprite. And then the width and the height are 16 pixels. So 0 source X, 0 source Y, 16 width, 16 height. And I'm just going to pick a random location on the screen to draw it for right now. I'm just going to say 100, 100. Completely random spot, doesn't really mean anything. Good. So now, if we run it, still nothing, let me close the GIMP now. Still nothing is getting drawn to the screen. You're probably saying, why is nothing getting drawn to the screen if we just added the player at a certain location? And the answer is because we're not drawing it. The draw method is still empty. So the first thing I'm going to do is I'm going to actually call draw here and pass it graphics, which is fine, but we still need to add some stuff in here. So we're going to first graphics.clear. Clear whatever's in the renderer right now. Okay? Then we're going to draw whatever we have to draw to the screen. Right now we only have the player. So I'm going to say player.draw, and it wants graphics X and Y. So graphics, and again 100, 100. This will all be stored somewhere else later on. We won't actually be passing it in here. But for now that's fine. And then graphics.flip to actually draw it onto the screen from the renderer. And now, without further ado, let's build. It all builds. We run. And there he is. At 100, 100, we have, quote, being drawn to the screen. Can't move him. He doesn't do anything, but he's being drawn. So we succeeded in our goal of drawing a character to the screen. So these are done. All that's left is this global variable thing. Now the reason I want to add global variables is because if you look, he's very small, too small. And in my notes up here I said all sprites are scaled by 2, I think. When I played Cavestory, the sprites seem about twice as big as they are here, so 32 by 32. The sprite sheets though are 16 by 16, each sprite. So we need to double it. So I'm going to go into my header files and create a new file called globals.h. Now we have to be careful in this file because we don't want to, anything global like this is scary because if we create a variable name and then create the same name somewhere else, we'll get errors, or if we use a name that's already defined somewhere else, we'll get errors. It gets very messy. So to solve that, we're going to put in a namespace called globals. Now we can't touch any of these variables unless we started out with the namespace name and the scoping operator. So we're going to put our screen width in here. This is completely unrelated to what we were working on before, but I think it's important to have it as a global variable so we can change it easily and only have to change it in one place. And then the important one for now, sprite scale. We're going to make it 2. So first we can go into graphics.cpp and replace, well, include globals.h and replace our width here, the 640, with globals scoping operator screen width. And then our height we can replace with globals, scoping operator, screen height. And then that's it for that. Then we can go into Sprite.cpp here. And what we're going to say is when we're making our destination rectangle, we're going to make it take up twice as much space. So to do that, we have to modify the width and the height. To make it take up twice as much space, that will pretty much draw twice as many pixels, and so it'll be scaled by 2 if we scale it evenly. So I'm going to multiply sourceRec.w, the width, times globals sprite scale. And then the same thing for the height. Let me put this on another line. Globals sprite scale. So what that's going to do is and also include globals.h, of course. Now when I run the program, oh, I have an error. Where is this? Macro name missing? That's ugly. Oh, that's because for some reason I wrote define instead of end if. So I don't know what I was thinking there. So now build everything, make sure it all builds, and then hit play. So this is the old one, this is the new one. You can see now quote is twice as big, and that's actually the correct size for this game. So now all sprites will be drawn twice as big to match this. That's it. So I'll close out of those. And that's it for this episode, actually. We accomplished all of our goals here. So now, let's quickly talk about next time. What are we going to be doing next time? Fun stuff. It's time to move quote around. So, we're not going to be actually moving his position next time. We're going to be giving him animations. So to do that, we're going to create an animated sprite class. That's going to extend off of our current sprite class that we just created. And it's going to handle all things for animations for sprites. And we're going to talk a little bit more about how sprite sheets work. I kind of went over it before, but when I opened up GIMP and showed you. But we're going to talk a little bit more because it's going to be very important next time. So yeah, we'll have a moving quote on the screen after the next episode, so be sure to check that out. So as a reminder, my name is Limeoats. My website is limeoats.com. My Twitter is @limeoats. This is the GitHub where you can find all of this stuff I just wrote. Again, I forgot to include my subreddit in here. So my subreddit is reddit.com/r/limeoats. So go there and subscribe because I post all these videos there immediately after they're uploaded to YouTube. Also, of course, please subscribe to this YouTube channel so that you can get notified every time I create a new video, and so you can stay up to date and ask questions while the video is still pretty new, so it'll be easy for me to answer them. So yeah, give me a follow on all of that if you'd like, and I will see you all next time. Thanks for watching.